So now as you know that what is the oxidation number, we are going to define the redox reaction in terms of oxidation number. So whenever you get to see increase in oxidation number, so obviously it is indicating the oxidation, and whenever you get to see decrease in oxidation number, it is the reduction. And we know that in a reaction we see oxidation, we will be seeing an increase in oxidation number also, and we will be seeing the decrease in the oxidation number also. So this is what is the redox reaction in terms of oxidation number. So now I have few problems for you where we will be indicating the oxidation and reduction, or an oxidizing agent and the reducing agent, by just focusing on the oxidation number. So see, this is the first question in which I have HNO3 plus H2S form NO plus S plus H2O. So when you get this kind of question and you need to tell that whether the which atom is undergoing oxidation and which is undergoing reduction. So what you need to do is that first calculate the oxidation number of all the atoms which are involved in the reaction. So let us find for that. So we say it has plus 1 minus 2. Let's find for n first. Plus 1 plus x minus 6 is equal to 0. So we have x, this minus 5 is equal to 0, and x is plus 5. So that means nitrogen has plus 5. Looking for on this, it has plus 1. So let's find for S. Plus 2, 1 into 2 plus x is equal to 0. So x is definitely minus 2. Don't relate it with valencies, keep in mind. For NO, again let's find for N. O we know it's minus 2. So x minus 2 is equal to 0, and x is plus 2. For sulfur, it is in elemental state, obviously 0. And for water, hydrogen, actually it is plus 1 and minus 2. So now as you can see that we will just focus that which atom, oxidation number of which atom is increasing and oxidation number of which atom is decreasing actually. So let's find that. Plus 1 for hydrogen, no change, plus 5 for nitrogen, and plus 2 here is the change, plus 5 to plus 2. That means the oxidation number is decreasing, so it is called as reduction. Let's find for O, minus 2 again same, S minus 2 and 0, it is increasing. So that means this is oxidation. Likewise, you can also indicate the reductant and the oxidant. You know that the substance which is undergoing reduction is an oxidant or an oxidizing agent, and the substance undergoing oxidation is a reductant or a reducing agent. So this is what is how you are going to define, or how you are going to find on the basis of oxidation number. Second question. Again, we need to write the oxidation number of all the atoms. I2, iodine exists in nature as I2, so again it is 0. For hydrogen, we found here also, and by the same way you will be finding for this way also. This is plus 1, minus 1, and this is again 0. So we see that iodine is getting changed 0 to minus 1. That means it is decreasing. So that indicates reduction, and it is an oxidizing agent. And this sulfur minus 2 to 0, that means increasing. So it is oxidation, or we will write the reducing agent. Likewise, we will be doing for the third one. Plus 1, minus 2, HNO3 we already calculated. So I am taking the same values. You are going to calculate but in the same way. Oh, this and this is actually same, right? Because here also it is HNO3 plus H2S forming NO, S and H2O. The same we have it here. So you are going to take this question in the same manner as we took first question. So this is how you are going to explain the redox reaction in terms of oxidation number. So whenever you get a question like that, just try to find the oxidation number for all the atoms, and please keep in mind, do not use the valencies as oxidation states or number, because oxidation state or oxidation number is something different from the valency, right? So because the oxidation number can be anything. Oxidation number can be anything in for any atom in any compound. It is just a residual charge. But valency is the combining capacity. That means the certain value which actually makes it stable. That is something else. So don't confuse with oxidation states and the valencies. Likewise, the valencies cannot be negative, but the oxidation states can be negative, can be in fractions, right? So there's a lot of difference between the oxidation state and the valency. So just what you do is that like whenever you see a question like that, just found the oxidation state, just see the increase, just see the decrease, and this is how you're going to predict an oxidation and the reduction, likewise the reductant and the oxidant. So now it's a time to balance these ionic reactions. I'll be explaining you the phenomena that how we can actually balance these ionic equations. So just look at it.